Hello there, it's Andy Ewens from FormaServe once again. Here in our 5th module, we will be continuing our bite-sized training on writing bash scripts for our IBM I. In this section of our bash scripting tutorial, we will take a look at how we can use data in bash, both accessing files and writing to files, all very useful. If you missed our previous video in this series, using functions in bash scripts, it can be found on our channel. Please subscribe to my channel to be notified when our next video in this series has been released. In this module, we will be covering how we can read files and output data in bash, and provide you with a neat utility to check servers and PCs in your network, which you can easily expand to provide further functionality for your business. All very handy. Let us get on with this topic of data in bash. The first command we need to look at under the data topic is read. Read can be used in many ways. The first way is to catch user input. Using read in this way is not truly associated with data, but a good nice to know and an easy one to get started with. Let me switch over to VS Code and show you a very simple example. Echo -n, which keeps the text and the input all on one line, and ask the question, in quotes, what is your name? Then read with a variable called name, and then an echo, hello, and the output the variable of name. Yeah, did say it was simple. Let me run this script in a bash window. read1.sh. It's now prompting me for my name. Enter the details, and it echoes back, hello Andy. If we don't use a variable name associated with a read, it will assign the content input into the variable reply. So if I extend this example, so when we ask what is your age, then a read on its own, and then echo it out, you are $reply. So that is how we can assign a read without specifying a variable name to it. In the above examples, we have used the echo command to prompt the user the questions that we are asking, and is commonly the way it is used. But we can just use the read command on its own with the -p flag to prompt the user. Again, to extend this example, if we code read -p, what is your name, and then an echo to say hello. All very straightforward. Hope you think so. Over to bash. Run the script read1.sh. Don't forget the sh, it won't like you. What is your name? It's asking. Mine, still Andy. Then it echoes hello $name. The next prompt, what is your age? 21, honest gov. And finally, a read asking a question, what is your name again? This time the reply being placed in the $name variable. So, all different ways to capture input from the user. Let me have a word about IFS. Not that IFS. The IFS is an acronym for Internal Field Separator, or Input Field Separator. The $IFS variable is a special shell variable in bash. Let us see what $IFS is and why you need to use it while writing shell scripts under bash. Let me explain the IFS variable in a quick example. Over to VS Code, as always. Firstly, I'll save the existing contents of the IFS variable into one called old IFS. Makes it easier to restore later on. Then we set up a string with some words in it. Then set the IFS variable to the space character. Then we will use read with redirection, cover that in a moment, to populate an array with the elements of the variable $string, using the IFS character of space as a delimiter. Then we echo out how many elements we have in the array. Next, in a for loop for each of the array elements, we echo out the array elements, which is now stored in the variable $val. Then we end the loop, and finally restore the IFS variable. Over to bash, see what we get. Call ifs.sh, And there we have 7 words with each of the words specified on a new line. Just what we needed. To make sure it is working, I'll go back and change my script on line 7 to use the vertical bar as a delimiter. Run it again. And as you can see there, it fails miserably. Before we get onto the main topic of data in this module, I want to have a quick word about redirection. Redirect operators are basic but an essential part of working with bash scripts. Hopefully this will help with the examples I'll be showing. Bash commands have one input, standard in, usually the keyboard, and 2 kinds of output. Standard output, std out, usually the screen or the terminal, and standard error, std err. Each I/O stream has a numerical ID. These are 0 for standard in, 1 for standard out, and 2 for standard error. These pathways are called I/O, input and output streams. However, it is possible to alter these input and output locations from somewhere other than std in and send the results somewhere other than std out. We use the shell redirection character, the right arrow, to dump the output of a command to a file. The right arrow will either create a file or replace its contents entirely if the file already exists. Doubling the symbol, so 2 right arrows, will append the new content to an already existing file without erasing its content. All very handy. In the first example, we will use redirection to create a new file for me. If we echo "Hello Andy" in quotes, then redirect it to a file instead of the screen, it will create the file for me. Then a cat hello.txt, and we can see its contents. A simple one to start with, all for that. If I run the command again, but changing the text to go to the same file, it will overwrite the original file. If I want to append the text to an original file, I use the 2 right arrows. And with a cat, we can see both entries. You often see the piping character being used in bash. Piping uses the vertical bar character. Piping is the same as redirection, but it only deals with standard in, std-in. We will be using the piping character later in our working example, so don't forget it. The example on the screen pipes "Hello Andy" into the cat command. Putting it simply, if you put this vertical bar after a command, it will pass the message on to the next. We have just talked about I/O, input and output streams. Well, what about error handling? How do we take care of errors? std err, standard error, is known as the standard error handling. Standard error, or std err, captures any errors that occur. By default, standard error writes to the terminal or the monitor. Just as we can redirect both input and output, std in and std out, we can redirect errors to go somewhere else rather than the terminal. To redirect errors, we use the number 2, as that is the file descriptor for std err, with either the right arrow to create a file or replace it. With 2 right arrows, you can append the error to an existing file. This is the most common way you see. Over to bash for a quick example. In this example, I'll run copy F, A to B, and redirect the output to output.txt, and any errors get redirected to the error.txt file. I'll run that, no error shown. But if I check output.txt file, there's nothing in there. But if I cap the error.txt file, we can see the errors that have been redirected to the error log. We can also use simultaneous redirection. In this example, the standard stream was identified by its numerical ID. This means that you can redirect standard out and standard error in the same command by specifying which one you want to redirect. Echo "Hello there", 1 goes to test.txt, and 2 standard error goes to error.txt. If I cat test.txt, we can see the input, hello there, to the file. If I cat error.txt, it is empty as no errors occurred. That is simultaneous redirection. Be aware, these can get very complicated. To get the syntax correct, it might be worth breaking the commands down and testing before you join all the redirections together. If we want to redirect both output and errors to one file, we can use command ampersand right arrow to a file, which will capture both standard out and standard error to the same file, which can be handy under certain circumstances. Let me show you some examples. Over to VS Code. Firstly, we will send the contents of the hosts.txt file and any errors to alloutput.txt. Then, very similarly, we will send the content of host.txt file, this time to append it to alloutput.txt with the two arrows. Let's see what we got in the alloutput.txt file. Back to bash, give it a run. Out error.sh. Let me show you what's in alloutput.txt. Here we can see all the host file first, and then the last line has the error as the host.txt file does not exist. An example of doing standard out and standard error to one file. We briefly covered the read command earlier in this video. Now we know all about redirection, let's take the read a stage further. We will take a look at how we can read line by line a file in bash. Read is a bash built-in command that reads the contents of a line into a variable. It is primarily used for catching user input, but can be used to implement functions taking input from the standard input stdin. Let me put this all together in a bash script to explain it further. Firstly, we assign the variable file to be the name of the file we're going to read. In this case, it's host.txt. Then in a while loop, read line. Inside the while loop, we echo the variable $line. Then on the next line, we use standard input stdin to redirect the name of $file, which is host.txt, into the while loop. Then if we run read2.sh, we can see the contents of the host.txt file, which we will be using for the rest of this module. In this next part, we will get bash to decide if a file exists. For this, we will use the test built-in function. The test built-in function is used to retrieve attributes and perform string and maths comparisons. Test provides no output, but returns an exit status of 0 for true, test successful, and 1 if the test failed. Over to VS Code for an example. In this example, once again, we will be using the file called host.txt and placing that name in a variable called file. Then in an if command, we use test with the -f flag to test if the file exists. If it does, we have a quick echo. If it doesn't exist, we let the user know with another echo. Over to my bash terminal to give it a test. Test.sh, and it tells me the file host.txt exists. All good. Let me move on to a working example we use here to check if a server is up and running. We have a CSV file with the names of the servers or hosts on our network called host.csv. This file has the server name, a description and its IP address. We will use this file as an input to check they are reachable using TCP/IP command of ping. If they are reachable, it will store the details in an output file called ok.csv. If they have an issue, it will log the details in an error log named errors.csv. It will also have an audit log to store the details of each command that is run. So, a mixture of CSV files and text files. With 4 files, let's take it step by step. Working through the steps we are going to perform, they are: Step 1, we will step through the host.csv file and echo to the screen each record. We will omit the first record in the CSV file as that's a header record. Step 2 will run the ping command to each record in the host file. Step 3, we will write records to the OK.csv file or error.csv file, depending on the results of the ping, and also write to the audit log. We will take each step and build the next step on top of that. Let's get started. Firstly, let me show you the host file we are going to use as the main input file. I'll open it in VS Code, and you can see that using an extension called Rainbow CSV, it has coloured the parts of each record, which is delimited with the comma character. Makes it easy on the eyes. First line, as always, good old shebang. Then we define all our file names. Input file is the host.csv file. The output file is the OK.csv file. The audit file is audit.log, just a text file for that one. And the one that we hope we don't use, the error.csv file. Next we get the current date and time for auditing purposes. Date in the format day-month and the 4-digit year. Then time in format hours, minutes and seconds in Navy format using the 24-hour clock. And then we will echo a starting script to let the user know what we are doing. Then we echo out the CSV headings for both the output file and the error file. You can see here we are using redirection, so the echo writes to the two files we have named. We only used one right arrow so that any previous details will get erased and we get a clean sheet for this run. If you want to append details to existing runs, then you would omit these two steps as they would have already been written to these logs. There are many types of commands available in Bash to show the contents of a file. Most commonly used are cat, more, less, head and tail commands. We will be using the tail command in this example. The tail will read the input file using the -n flag, which will start at line number 2. So this will omit the headings of our CSV file. Using the pipe directive, the vertical bar, it will feed the contents into the while command. The while command sets the delimiter to the comma character. Using the IFS flag, yes I know, not that IFS, it will pick up the columns host, IP and description. The underscore character at the end ignores all other columns. Next we have the do command associated with the while command. The code within this block gets executed for each line of our CSV file. In this first attempt at the coding, all we are going to do in this loop is to let the user know which server we are checking using the echo command. And next we wrap up the block with the done command. And that's it for now. Next we have a test to ensure it's reading all our records as intended. Over to my terminal session and called example1.sh. Firstly, we can see the start message with the current date and time. Then we have the second line of our CSV, checking our server called Sun, and then line by line each of the other servers. I've just noticed we haven't got a completion message there. Failed. I do like keeping the user informed of what's happening in my programs, and it also helps debugging. I'll add that to the next example. Within our do loop for each record of our CSV file, we need to ping the server to check if it's up and running. Firstly, another message to the user to let them know what's going on, telling them that we are pinging the name of the server using the variable $host, which was populated as part of line 21. The ping command will be enclosed within an if statement depending on the resulting code back from the ping. Let me explain. Due to IBM I not having a native ping command within the PACE environment, I've used the system command passing ping as the parameter to get round this. I will be covering system in a lot more detail within the IBM I specific module of this series. You can see that using the system command requires me to pass the flags or parameters of -b, o and e. These are all to do with character sets and will be covered in full details later on. So if system ping, then I redirect the output of the ping to what is known as a null device. Whatever you write to /dev/null will be discarded, forgotten into the void. I do not care about what the ping outputs, I'm only interested in the return code from the ping. To round that line off with a then command. If we get a good return code from the ping, we set the variable ping_status to OK. Then an else command to set the ping status variable to fail. And then we end the if block with an FI. Oh, I do like that. Next an echo to let the user know what the status of the ping was. Then we round things off by updating the date and time variables and outputting them on the screen. That adds the bit I left out last time. Back to my bash terminal to test it out. Example2.sh, all looking good. And on to the third part of this working example, where we will write the details to the various files. Firstly, let me write a line to the audit log to recall our starting point. Then down to where we get a ping back and know it's a success, we want to write those details with an echo to the output file. If it fails the error, we echo the fail to the error file. Then outside the ping check if block, we write all the details to the audit log. Note this time the audit log is a text file, so no need for any comma delimiters. And finally, when all the servers have been checked, we echo a completion message to the audit log. And that is it. Over to bash to give it a test. Example3.sh, it chugs through the list of each server and now it says it's completed. Let me check out the output files. Here we can see the 3 files in VS Code. Blue for the good file, red for the failed file, and pink for the auditors. I bet I'll get in trouble for saying that. All looking good to me. This was a working example of how we can easily use bash in our day-to-day workings. This example could easily be enhanced to maybe checking DNS servers, SSH servers, etc. etc. Give it a go and let me know how you get on. Good luck. And that wraps up this topic on accessing data in bash on the IBM i. I hope you enjoyed it. Look out for our next topic in this mini-series on bash scripting, creating menus in bash. Subscribe to our channel so you'll be informed when the next video is available. The link is in the description. If you need any further details about open source or IBM i, check out all our videos at learning.formaserve.co.uk and the articles we have written for Powerwire.eu. I hope you find them useful and let us know if there are any other topics you want us to cover. Even through these difficult times, my company, FormaServe, is still providing training on our favourite platform, the IBM i. Whether it's remotely, through a mask, we are still here for you. If it's traditional programming using RPG and CL, or the modern methods of integrating open source into your infrastructure, we are here to help. We have over 30 years of teaching on the IBM i. Why not use us to get up to date and be at the forefront of the post-pandemic world? FormaServe uses Microsoft Teams software to develop top-notch training material. Take a look. You will not be disappointed. As many students have found, all our training is very informal. It's the way to learn. Find out what it's like to have fun while training. And that wraps up this quick video. Thank you for watching our how-to on IBM i video set. I hope you found them useful. Keep checking out our website learning.formaserve.co.uk and our YouTube channel. We regularly add new ones. Stay safe and we'll see you soon. Thank you.